My name is Audrey Lowe, and I'm doing calculus in Magikarp Jump. So I first wanted to go over what is a Magikarp, which is a fish Pokemon, and Pokemon are fictional creatures that live in the fictional world of Pokemon, created by Satoshi Tajiri in 1989. And they are regarded as the most useless Pokemon, because their Pokemon move, which is an ability Pokemon can use during battle, is Splash. And Splash does absolutely nothing, except it allows a Magikarp to jump up to very high heights. Although they cannot change direction in the air, so they just land right where they started. So, fun fact, female Magikarp have white whiskers and male Magikarp have gold whiskers, which I didn't know until I started really playing the game. And Magikarp Jump is a Pokemon game where you raise Magikarp, you can fish up different Magikarp patterns, and you feed and train Magikarp to gain jump power, and you can to compete in league battles. And league battles are where you have Magikarp compete against each other to see which Magikarp jumps higher. And what I wanted to know is what is the jump powers relationship with the meters jumped? So first, data collection, my test subjects. I have Onion, Failure, Experiment 3, and Mishmish. Right off the bat, Failure lives up to his name by evolving into a Gyarados, which, since this is a Magikarp-based game, absolutely terrible. So I banished him after I gave him to that old man, which changes my test subjects back to here. So for data collection, I just played the game. So after the battle, the league battle, they'll give me the meters I jumped and my Magikarp's jump power. So I just collected these and put it all into a table on Desmos. So I had some really high ones and some really low ones. So I chose to use Desmos instead of the calculator because the calculator's domain was extremely small and it just would not calculate. So I put it on the table, and this is a bigger view of it. And line of best fit fought me. So I tried doing a ton of different formulas to calculate it, but they did not represent the jump power meter relationship as well as I wanted. Like this one, it can't be seen here, but it started going down to negative infinity, and I think on the last page, one of them went up to positive infinity, which was just not what I was looking for. So I started doing a ton of ln, or natural log equations, which I just settled on this one, and this one is the Desmos calculated one. This is the calculator calculated one. I was only able to get this because I got rid of a few of my points, so it wasn't as accurate as this one would have been. And even though the R squared is only 0.8564, I think it represented the jump power meters relationship better than any of the other ones did, even though it was the most accurate to my data. And just a reminder that it's the jump power meters relationship here. And here I have my line of best fit. And I have a domain of 1 less than equal to x less than equal to 28,459,572,353, because that is the max amount of jump power you can get. So this is just stuff I was curious about. I was curious what is the average value of a jump power, which is 126.830. And I went and found the derivatives too. So my function was called z prime, and I found the derivative of z prime. Since it was ln, it was really easy. So it was 6.90701 over x, and then this would have been negative 6.90701 over x squared, but it's written as x to the negative 2. And I have that I wanted to look at was Z double prime is negative and Z prime was positive, so that meant the graph was kind of slowing down of Z prime. And obviously there's just some givens that Z double prime is negative the entire way, so this was concave down the entire way, and this was negative. And with the double Z prime, that just meant the exponential curve was just slowing down. And now, here's a fun game of spot the difference. So there's something wrong with one of these Magikarp up here, and I'd like to ask my audience if they think they could figure it out. Okay.
Is it by any chance the bottom right?
No, actually.
Oh, that's where I was going to. God, that was one of the answers.
Anyone else want to guess? Okay, so the answer is actually this one, because this is a shiny Magikarp, and a shiny Magikarp, it just means it's a shiny Pokemon, and shiny Pokemon are just Pokemon with rare color discolorations. So these are common patterns, including this one. So that is probably the most common pattern of Magikarp, and that one is shiny compared to the other ones. It's just a nice break. So story time too. So there's a Chinese legend called the Dragon Gate, and in the Dragon Gate you have thousands and thousands of Magikarp migrating up the Yellow River, and until they get to this waterfall. And a lot of the Magikarp at this point, they turn back because it's loud and scary, and they don't want to deal with the waterfall. But the strongest of the koi fish, not Magikarp, they keep trying to jump over the waterfall, and they try for hundreds and hundreds of years until one finally makes it to the top. And now, because of this great achievement, the gods turns this koi fish into a dragon. And this is important because Magikarp are based on koi fish. So that got me thinking. Based on this legend and my equations, can a Magikarp jump over a waterfall? And first, yes, because I searched it up, and a waterfall at minimum is 1.524 meters, which falls right there in my data. Very low. So I went to the waterfall in the legend, which is the Hukou waterfall, which was only about 20 meters and fell right there in my data. So I said that was weak. I'm doing the largest waterfall in Angel Falls in Venezuela at 979 meters. And so I set that equal to my equation. I solved then for x and found that for my jump power, which is unfortunately completely out of my domain. So no, my Magikarp cannot jump over Angel Falls. So I just got me curious about what my maximum and minimum values were. So the highest that Magikarp can jump is 133.73 based on this. Then that means they can jump over Nashi Falls in Japan at 133 meters. But then I got a reminder that during battle, you can have a companion Pokemon that cheers for you. And there's an animation loop where it blinks and it blinks. And if you click at the right time, you can get a 5% jump power bonus and then a 25% jump power bonus if you click it at precisely the middle. So I got two new equations where I increased this one by 0.05% and by 25% by multiplying by 1.05 and 1.25. And these are my graphs. And here's a wider shot just to show the significance of that. So then I found the cheer bonus total difference in meters. So I took the area between two curves of the 0.5 of the 5% bonus minus the regular one, and the 25% bonus minus the regular one, which is actually a tremendous amount of meters in difference if you get these bonuses during league battles. So then I also found their minimum and maximum values again, which is 140 for, and I really wanted to look at the maximum values because these are our new waterfalls. And the 5% gave me about 140 meters, and the 25% gave me about 167 meters. So that means a Magikarp can jump over the Fossa waterfalls on the Faroe Islands at 144 meters, and the Solagad waterfall in Nepal at 167 meters.